Now that we know about the idea of dimension for any vector space, including known vector spaces or a vector space that's a subspace of another vector space or a vector space that's a span of a few vectors, right? We have various ways to describe a vector space, but we could talk about the dimension of any of those. Before we move on to rank, we should talk particularly about dimension of two particular vector spaces, namely the dimension of the column space of a matrix and the dimension of the row space of a matrix. Both the column space and the null space of a matrix are vector spaces, so they have a dimension. And since they use these nice three-letter abbreviations, we get to write down cool things like we want the dimension of the column space of A, and we also want the dimension of the null space of A. So the column space, let's tackle that first. The column space, the columns are members of R4. They're four-dimensional columns. At most, then, the dimension would be 4. Right? Once you have 4 linearly independent vectors in R4, you have spanned all of R4, and you don't need any more. So at least 2 of these are extraneous to the column space. Maybe more, we don't know. It's hard to see, well, actually, in this particular example, it's not too hard to see that the second column is 3 times the first column, so that second column is not going to need to be part of the basis for the column space. But in general, we know that the basis vectors for a column space are what? That's right, the pivot columns. So we would need to do the row reducing. So grab your favorite row reduction calculator and look at where the pivot columns are. And it turns out the pivot columns are in the first, third, and sixth columns. Again, we knew that second one wasn't a pivot column because it's 3 times the first column, and actually it looks like the fifth column is 2 times the first column. Yeah, sure enough. Okay, so it would be the dimension of the column space would be 3, because we know the basis for the column space is that one, and that one. But we don't even need that if the question is just dimension. We just need to know how many vectors are in the basis for the column space. So there are 3. So the dimension of the column space, 3. Dimension of the null space, you might think that would be a little bit harder because it's harder to find the basis for the null space. Right, that takes a little more work. Turns out if all you want to know, though, is the dimension of the null space, there's a shortcut. But we don't know what that is yet, so let's do it the hard way. Let's go ahead and just actually find the basis for the null space of this thing. So to do that, you would sort of put x's and whatnot back onto this. So this first row says something like x1 plus 3x2 plus 4x4 plus 2x5 plus 0x6. And when you're looking for null space, you're looking for that all to come out to 0, right? There, you'd augment it with a column of zeros over here as your 7th column. But anyway, that's the first equation. And normally we like to solve for x1. So let me go ahead and rewrite this one real quick. It's actually x1 equals negative 3x2 minus 4x4 minus 2x5. And you can tell those are going to be our 3 free variables, x2, x4, x5. They're the ones that aren't the pivot columns here. X2 is a free variable, so x2 equals x2. X3, now I'm working on the second line here, so x3 minus 2x4. That's it for that one. So x4 and x5 are the other free variables. x4 equals x4 and x5 equals x5. x6 has to be 0. So just put that there somewhere. But really the basis for the null space is made up of 3 vectors. Some multiple of x2, some multiple of x4, some multiple of x5. If I wanted to write it out a little bit, I'm going to move over here so I don't write on top of my face. So that'd be negative 3, 1, 0, 0, 0, 0, 0, 0, 0, 0 for x2. I could do the same thing with x4, and I could do the same thing with x5. I'm not writing the numbers in because the question was not what is the basis of the null space. The question was just what's the dimension of the null space. As soon as I knew that there were 3 free variables, I knew the dimension of the null space, right? Because I knew that it's going to be some vector times the first free variable, some vector times the second free variable, some vector times the third free variable. So the free variables are the ones that aren't pivots. There's 3 of those here. So notice what we have is like 3 pivot columns, and the remaining ones are free. I feel like I should use a different color. Okay, free, free, free. And every free variable is a dimension for the null space. So it is no accident that there were 6 columns and the dimension of the column space and the dimension of the null space added up to 6. That will always be true for any vector, or sorry, any matrix anywhere in the universe. So let's jot that down. That's worth having as a theorem. So dimension column space of A plus dimension null space of A equals number of columns in A, in the matrix we're looking at. And again, the dimension of the column space is the number of pivots, and the dimension of the null space is the number of free variables. And since dimension also tells us something graphically about how much space these things occupy, we know something fairly deep about matrix A now. We know something about what its columns do and what parts of it map to 0 and how much space gets compressed down to 0 and how much of space expands to fill all of R4, or in this case not all of R4, only 3 dimensions of R4. We'll eventually go on to essentially do the same thing, not working across the matrix, but working down the matrix, looking at the rows. We'll do that later. So for now, there's a question or two in your homework that just ask you about the dimension of the column space and the dimension of the null space. And all you really need to know is how many pivots, and then subtract from the number of columns to get the dimension of the null space. Nicely enough, in your homework, they give them to you in reduced form already, so it's very easy to see the number of pivots. All right, next video we will talk about rank.